And you might think, well, how does that prove that light is a particle? There were so many little conditions that emit. If electromagnetic radiation was a wave, you could keep shining the light, the intensity of the light, and eventually electrons will be emitted because you'd eventually give it enough energy. But that's not the case. You needed a certain discrete amount of energy to get those electrons off the surface. And that was determined by frequency. E is equal to hf. In this case, the electrons were emitted immediately once the right frequency hit. There is no delay as would be predicted if EM was a wave. The number of electrons emitted per unit time was directly proportional to the intensity of the light, i.e., the more photons you have, the more electrons you emit. There was some equal value between the photons and electrons and emitting them off the metal. Furthermore, the maximum kinetic energy of these electrons was independent of the intensity of the light. So instead of having more energetic electrons, you had more electrons. If EMR was a wave, your kinetic energy of the electrons would be increasing. But instead, it was just the amount of electrons that was emitted that increased. This is where we ultimately get this infamous equation. Kinetic energy is equal to hf minus the work function. Hf is basically the energy given by the photon, and F is the work function. This is the minimum energy required to emit an electron off the surface of the metal. The energy of the photon is split into two things. First, the movability of the electron, i.e. its kinetic energy, and the energy used to get it off the surface. The work function of the metal is a baseline value for that specific material. Stay curious.